So let's have a discussion with Millennium Machines. We're here with a few members of the team. Jake, why don't I start off with you, and then you can go through maybe everyone else.
So my name's Jake. I'm the guy who started it all. I'm from I don't know what you want to say. You want me to say originally? To be honest, is there anything specific you want to know?
Oh, just so Jake England, the project head. Well, and why don't we go to Dave?
Hey, can you hear me?
Yeah,
Okay. I can hear
absolutely.
you guys. Yeah, you hear me. Perfect. So I'm Dave. I joined the team pretty early on. Been following Jake's build since very early on, years ago now. Before V version 1.4, I think it was, even before that maybe. And I got hold of his very first V 1.5 and was kind of the person that started streaming at the machining videos with his machine for a couple of months when he didn't have access to space, and the project just seemed to grow very rapidly after that. Yeah,
Excellent. And
I tend to
Excale?
be the one that
Ooh,
does the breaking of the stuff.
sorry. Excale?
So I'm Excale. I joined a few months after the V1.5 drop, I think. I think that's correct. I was initially here to improve the documentation and to maybe give a bit insight into how to format things in open source, as I do software development on the daily. So, and currently I've been working on the print it for me or print it forward part of the project. So to make sure that we have trusted vendors of printed parts throughout the world.
Yeah, that's very important. I've seen photos of some less than impressive printed parts not coming from any of your printed forward people or anything, but it's like, okay, so that spindle mount has about 3 millimeters of deflections at the ends. Is that okay? The answer is no. It is most certainly not. So thank you.
I also try to answer most questions on the Discord and try to get in touch with, for example, the people that printed those parts.
So. Well, thank you. And certainly not least, 9 Mile.
So I've been part of the Millennium Machines team since about August, September last year. I finished the build of my Milo in June last year, and then proceeded to spend a bunch of time trying to work out how to actually use the thing, realized there was a big gap there, and decided to write Millennium OS, which I think we've talked about before, but is essentially just designed to make the machine easier to use if you don't have a machining background. So that's mostly what I've been working on, and documentation.
And I can attest that your work is working, because I had literally never run a CNC mill, barely run a CNC at all. We have one of those snap makers at the shop, which is a combination 3D printer, CNC, and laser cutter, or laser engraver, we'll say. And outside of doing some really bad ACM panels with it, have never done anything. So the fact that I can take something that I designed in Fusion 360 and then successfully mill that is in no small part due to the work that you've done. So thank you.
You're welcome. It's funny, actually, because you effectively have more CNC experience than I do. I only actually started using machine properly maybe 2 weeks ago to actually try cutting stuff. So I've just been testing my own code at that point.
Lovely. So how did all of this get started?
It's a very, very long story. So basically, I was working. I'm an outdoor instructor. I'm by no ways a trained engineer. I work in mountains and rivers and things like that. And I was at university studying this, and it came to the end of my first year at uni, and I went to go work at a camp, and it was barren there. There was absolutely nothing. It was like an hour's walk from the nearest town. No one was allowed their car on site, stuff like that. And that's just what you expect as an outdoor instructor. And some old geezer from down the road was selling a 3D printer, and all of us got together on the camp and decided we're going to put like a tenner all together in for this printer. And I think I had the majority stock in it or whatever. And we just used it to keep ourselves entertained effectively. So I took that CR10, I think it was a CR10 home with me at the end of the camp. I didn't know how to model anything. So I decided, okay, you know what? I'm going to learn how to model. And I think it was at the same kind of time that the MP-CNC was catching on. So I built my MP-CNC and thought, okay, this isn't the greatest machine in the world. I get where it has its little niche, but we've definitely moved on from using steel pipes as linear guide rails and things like that, in my mind at least. So I kind of took it upon myself to challenge myself to design something and learn how to design. So I thought, you know what, I'll design my own CNC machine. I had no idea or like no intention to actually make it in the end. And I found a few YouTube channels who were going on about the Open Builds mini mill, and it was basically Milo but with V wheels and way worse in pretty much every single way. And I thought there's some basic upgrades that I can make to this thing to make it worthwhile. Uh, and I started. I think it was a Reddit post somewhere. I think it was on r slash 3D printing or something like r slash CNC, where I said, okay, I'm doing this as for fun. What do people think? And I got, I think, 100 responses saying, oh, where can I have the STL files? You know, the classic 3D printing, just STL, STL, STL. And they all got back to me saying, oh, you're going to make this thing. And effectively, Milo was born through peer pressure because of that day. So I started pushing pushing releases to GrabCAD for a very long time, and this was pre V1.2 levels of this, and kept going. And then I released V1.4, and it was the first actual full release. So it was the first time we had a full BOM. It was the first time people could actually build it themselves, and it was a complete machine rather than just tiny iterations on the same machine. And people were interested in it, but we had a lot of people who just didn't care for a startup project or things like that. They were all interested and they wanted kits, but it wasn't really a thing. So Dave hopped on board at that point in time. Or was a little bit later, yeah. It was when I released V1.5, which actually isn't that much of an upgrade over V1.4. There was a few dimensional changes, but it was mostly an aesthetic change, to be fair. And then Dave got my first unit because I was living with my girlfriend at the time in a tiny little flat and I couldn't test it. So I gave it over to Dave. Dave ragged the hell out of the thing, and started actually putting videos out there, and people got really into it, I'd say. So we set up the Discord. People were just flooding in from all around. People were really interested. And then one day, I think we had 500 people in the Discord. I just turned around, found Jason from the Voron Discord, sent him a message, and said, do you want to build us a kit? Or could you please build us a kit? and I expected to just be shot down entirely. Right? I did the same thing with Hector from Fabrico as well. And I think it was within a couple hours of each other, I got a message back from Hector saying, "Oh, this is great. Can we fund the project a little bit?" I was like, "That's awesome." And then Jason turned around and said, "This is great. It looks like you're still using a really awful printer. Do you want us to send you a Trident?" It was like, "Yeah." And from that point on, we started just growing the team, and V1.5 became popular. Then FMJ became popular, and I'd say that V1.5 now is very different to the V1.5 I released. Yeah, in a lot of ways. So yeah, that's the long story, not so short of it.
No, it's very interesting. We're talking just what is it, a couple weeks or a month after the Rocky Mountain Rep Rap Festival, and I had my Milo there, and there were a ton of people that either are anxiously waiting to get their kits, or have kind of heard some things and were very interested in learning more about the machine. It was funny. Jason did stop over to say hello and said it was the first time he'd actually seen one assembled in person. So that was fun. But you can definitely, my experience coming away from that show is there's definitely more interest in hobbyist CNC mills at this point. Between the Milo, Voron was showing off their Cascade design. The Rat, was it Rat? Is it Rat Rig Mill or just the Rat Mill? But there's the Rat Rig CNC mill.
The Stronghold.
Okay. Which you can tell they share some common lineage in design philosophy, at least. Both kind of looking back at the open builds. And it's another one of those things where, if you're talking about 3D printers, there are only so many ways that you can build a bed flinger. Whether you think it's, the ANET design or the Ender 3 design or the Prusa design or whatever. So, yeah, I think there's a lot more interest in people saying, yeah, I actually could have a mill in my house. Because the advantage of something like the Milo is, you can get it in less space than a traditional, the other style sort of CNC router, which is great if you want to do panels for a 3D printer or signage or whatever, but those just require so much floor space. Comparing, yeah. Well, before I got the Milo, I was thinking about getting more, a CNC router, and for what I wanted to do, the 3 foot by 4 foot footprint of the Milo seems very small. If you want to be able to cut and engrave panels for, like a 350 millimeter Voron, your work bed needs to be pretty sizable.
Yeah, it's a weird thing. We always talk about in the 3D printing world how it was all Prusa clones for a while, right, for a very long time, and people hated that. Whereas in the CNC world, we've had the Shape Oko for about 10 years, and the router style CNC machine has been the standard for hobbyist level, and it just hasn't changed for ever since the first Shape Oko came out. So it's been 10 years of stagnation, and that's why I think we did well with Milo. Milo, if you have a garage, if you have somewhere you don't mind chips being flung, doesn't take up very much space, right? And it's great for an environment like that. Yes, if you're going to run it indoors in a flat like me and 9 Mile do, you're going to need a big hefty enclosure, and we do understand that that's a limitation for a lot of people, right? But I think Milo was the first step in people realizing that there are different geometries of machine out there, same way that Core XYs were a thing. Those were the first steps to figure out that you can push a 3D printer in a different direction. And looking out towards the other projects, I'd say like Voron, the Cascade have done a Portal style machine well, the best that they can. I still think there's a limitation in that style of geometry, and that's no shade thrown at Voron at all because they do some incredible stuff. And I don't want anyone to misconstrue it in that way. I think the Cascade's going to be a decent machine. But just, I think Milo was that. That's more. I think Milo was, in one way or another, just a big push for a lot of people to realize there are other geometries out there.
Yeah. Yeah, and as we've seen in 3D printing, there certainly is room for any number of different machine designs and geometries. So at the end of the day, it just comes down to which machine is the correct tool for the job that you want to do. You know, the same way there's absolutely nothing wrong with a CNC router type machine. If you want to cut large panels, that's what you need. But if you want to machine thick, and by thick, I mean, you know, like over, say, 10 millimeter thick aluminum, then a CNC router design with that kind of gantry might not be the best option for you. Ultimately, you have one of everything.
Yeah, exactly. And we have done it in the past. Like I've been very straightforward with a lot of people. So many. If you need to do sheet work, if you're cutting less than a millimeter thick aluminium, but in a large sheet, or you're doing carbon fiber, or you're doing MDF, probably go with other projects like Print NC. Print NC is run by a great guy. The project's really good. The machine's really good, right? Um, but it does have a disadvantage in that, like you said, thicker material because of the way it's mostly the way the Z-axis is set up on routers because they can deflect a lot because of how they're designed. So us as a team have been we really kind of hammered it into the community that we're offering a solution for a specific problem, and not to take us and throw it out to the rest of the world saying this is the best, because quite frankly, there's a lot of situations where Milo isn't the best. Right? There's a lot of situations where Milo is also absolutely brilliant, and you need to find that as the end user, and we're not going to push you in one way or the other.
Yeah, well said. So, yeah, the CASA I think is going to be key for a lot of people. Um, I know it would make my life a lot easier. Um, even I've got some boxes from the shop that I just put up around it like a fence. But that still somehow does not manage to keep all of the chips in place. And I've printed one of the spindle fans, which I've run a couple of times, and it's fantastic. And I'm not going to be able to use it until the machine is in an enclosure because I can just see it launching, you know, chaff all over the garage, which then, you know, my dog will wind up tracking into the house, and that doesn't make anyone happy. So I have some large boxes full of CASA parts waiting for the kit to get here. I keep pestering Jason about it.
Nice, yeah. I know there's 2 beta kits that have been sent out for CASA, and I'm not sure I'm allowed to say who has them, but they are fairly close friends to the project, and they're being built as we speak. The moment they finish with those and give us some feedback as well, then we'll be able to make the final changes to everything, and it'll be out there. because it's not like Milo. There's a lot less that you need to sort out, especially with the way LDO I think is going to be handling it. They're basically going to treat Milo as its own thing, and then Casa as an extension to Milo.
Yeah.
Rather than it being its own full kit.
Yeah. No, LDO has done, they've always been fantastic. And they've been very good and very fast getting out some of those minor revision kits with the Milo itself. So that's all good stuff. So do we want to jump into some fusion?
Yeah, let's do this. I'll let Dave and 9 Mile head this one because they're a lot better at this than I am.
All right. Well, let me pull up. Okay, so everyone's seeing the HOI there.
Yep.
So imagine, let me just move this down so I can get to my navigation nubbin there. Imagine I am someone who has no CNC experience that wants to mill this part. Yeah. Now,
Do you want to go or do you want me to, 9 Mile?
I think it's probably on you first, Dave, seeing as I haven't actually made the HOI.
Yeah, fair play.
No problem.
well,
So,
well,
let's look at the part itself then. So, as you can see, Fusion's already done a thing for you. When you're working with machining, it's obviously the opposite of 3D printing. So you are removing material instead of adding material. So subtractive manufacture instead of additive manufacturing. And what that means is you need to start with a block of material somewhere, something to start from. Typically they're squares or cylinders because that's a nice generic shape that can be held onto easily and be bought easy in standard sizes. So what you're looking at on screen here is obviously the HOI part. So that's your solid grey object in the middle, the actual part you want to end up with. And Fusion has gone ahead, or you've preset up the stock material around it there.
yes.
That's the translucent yellow block, essentially. And now our goal with what we're going to do when we set up the rest of these toolpaths is to go from that block to the finished shape. In an ideal world, you do this in a single setup of the machine, and you do it without having to do any tool changes, because we have a machine that has no auto tool changer. So any tool changes and any setup changes they're like time sinks essentially. They're manual interventions where you can mess something up or something can go wrong just from the basis of human error. So you want to minimize those where you can. Although 9 Mile's helping here.
When you say setups, you mean rotating the part, essentially changing the mounting of the part on the table of the machine.
Yes, exactly. So if you look at this part, it's got features that are predominantly visible if you were looking top down at the part. So if you pretend you're the spindle and you're looking down at a component mounted onto the table, those are essentially the features you can access on a 3-axis mill. You have no way really of getting around and underneath anything. So you can only really do line of sight features as if you were the spindle on a 3-axis CNC in a single setup, as 9 Mile said, which is a single instance of placing the stock material on the machine and then clamping it in place. So whenever you're looking at a part like this, the first thing I would do is I look at it and say, okay, if all these features are accessible from one side, I can probably do almost all of my machining from one direction. And then I can flip it over and just machine any leftover bits off from the bottom. that's kind of what's called a top hat style machining process, because you essentially end up with a part with this little thin brim all the way around the bottom. Its side-on profile looks a bit like a top hat.
Do you mind if I just jump in for a bit?
Yeah, jump in.
Yeah. So just like Dave said, figuring out what features that you have access to at the beginning of any setup is probably the most crucial thing that you can do. Some features in machining don't require as much precision. So, for example, the 2 access holes that you have on the HOI part, they're not a precision feature. So identifying what features need to be precision ones and what ones don't need to be precision ones can save you a lot of time. So on an HOI, for example, like I said, the holes aren't a precision part. So therefore, if you wanted to save yourself some time and make everything easier, I would do a top hat style. So go from the top, do all the main features, then simply take it over to a drill press and do those 2 holes. Right? It's one of the things that a lot of people who start CNC work get a bit too trapped into. It's the whole, if you have a hammer, everything looks like a nail type approach. But if you have a drill press, some features just do not need CNC ability to do. Yeah. And I'll let Dave finish off there.
Well, yeah, even to add to that, if you've got a vise and a decent steady hand, you can measure and mark out the holes and drill them by hand as well. As you said, they're clearance holes. You just have to get them straight enough that your clearance accounts for the bolt being able to move around in it and do it up nicely. I forgot where I was. Oh yeah, so top hat. So as we just said, identifying your features is the first point. Working out what you actually need to achieve and what material you need to remove where. The next step is working out how on earth am I going to hold this thing. And what's called work holding in the sort of CNC world is an entire industry in its own right. It is absolutely huge, the options you have for approaching these problems. As a hobbyist, realistically, there's a few sort of standard ways that will be within your budget that you're likely to see and use. So the immediate obvious one is a vise. So a vise will be able to hold any piece of stock that basically fits within the opening of its jaw sizes. Bearing in mind, you can normally overhand your stock either side of the jaws because the jaws move in one direction. So you can normally hold a longer piece, but there's considerations to be made there on how stiff your setup is. So you don't want to hold a really long spindly bar and try and do something on the end of it. You want to be working as close to those vice jaws as possible where the material is supported. Which brings me to the next point, you can use more than one vice in a single setup. So you can have a vice holding each end of the part. An important part with vices, particularly on Milo or other CNCs that are small, is you want to have one with very low profile clamping jaws, because you have a very low profile overall in terms of the height, because everything you put underneath the bit you're working on eats into your work volume. It's not like a 3D printer where if you've got 200 millimeters of build volume, you get 200 millimeters of part. Here you've got that height minus the height of the vise, minus any other stock you've got underneath the actual part itself. So it has quite a big effect on what you can do in the end. The other sort of options you'd be looking at are simple toe clamps, which are basically it's like a flat bit of metal with a hole for a bolt. You raise one side on the back side on a little plinth, and then the front side clamps down onto the bit you're holding, and you just screw it down. You can use the T-slot extrusion areas with some slot-in bolt T-nuts to screw those down. You don't even need to have a fixated plate. Or you can use the fixated fixture plate and the pre-threaded holes that are on there for those points. Those are probably your 2 go-tos to start with. And if you look at this part we've got here, the stock material is a rectangle. It's not that big, so immediately I would be thinking, let's put this in a vise. It fits on my Milo, so that's what I'd do. If you want to just rotate the part for me, so you're looking side on. Yeah. So you can see you've already done this here. So you've thought about this. So do you want to just prompt us so it's not just me talking the whole time?
No, that's
Do
all
you want
right.
to say why you put the part where you've put it within that stock? So you've set your stock based on the size of the material you've got to hand. That's perfect. Why have you put the part where you've put it inside that stock?
I had put it closer to the top so that you're only, I believe this is a 1 millimeter offset, so that you're essentially just doing a single facing operation to go from the stock to the top of the part, and allowing me a little extra room at the bottom for my end mill to come down to be able to reach without getting too close to the jaws.
Exactly that. So as you,
that's perfect.
yeah, exactly. So as you say, you just that extra step off from the bottom is to give you clearance from those vice jaws, so you don't risk cutting into them. And then at the top, you've left a mill. That's totally fine. You might need to leave slightly more on some setups, just based on trying to remove a similar amount of material from top and bottom. If you're worried about any residual stress in the material you're machining causing it to warp, when you just take loads of material off one side, that can cause it to cut down towards that side. But in a bit of aluminium this size, particularly if you buy the tooling variants, which have been heat treated and so on, to relieve a lot of those stresses, you typically don't have to worry about that too much.
Okay. Give me just a moment. I need to look at something here, and I had a feeling that was going to pop up on my screen. Okay. I keep seeing out of the corner of my eye that there's some warning popping up, and I don't know what it is, but I wanted to make sure I wasn't running out of disk space. So yeah. Go ahead.
No, go ahead.
So no, it's a good point about maybe wanting that to be a bit more symmetric. So in general, at least for myself, let me move this back. Milling, doing the first operation, or the first couple operations, because I would assume we would do an adaptive clearing just to get the majority of the metal out of the way, then maybe do a contouring pass to clean up.
Mm-hmm.
This gets me to the point of where the first part where it falls apart for me is then, what we're going to have to do, obviously, is flip this around to be able to mill the bottom.
Yeah.
And in an ideal situation, we would have our vise clamped here and here to give us the least unsupported material. But we've got this big round bit in the way of doing that. So for this part, then we really are talking about soft jaws.
Yes, that's correct. You could possibly clamp the flat edge and the two other flats on each side, but the design of it itself in compression like that is just going to act like a spring. So it's just going to flex when you try and tighten that jaw up, and that's obviously not what you want to do. So you're right that you want to end up with a soft jaw that's going to clamp in the middle there.
So one question I had is, I've seen some soft jaws even for this part. I think it was Philip's setup when he was making it. Is it required to have a jaw on both sides, or can this surface be up against, let's say, the fixed side of the vise with a soft jaw on this side to accommodate the radius?
So no, there is not any fixed requirement for having a soft jaw on both sides. Often the shape of the part tends to lead to that being the case. Once you start cracking out soft jaws, you don't normally have a nice flat like this. the advantage possibly of having a soft jaw on both sides is that you can essentially machine both sides of the soft jaw once they're installed, so they're exactly the same height. So you don't then need to try and make sure that your soft jaw that you're machining just one side of perfectly aligns in terms of height with your existing jaw.
Okay.
That's probably the major benefit, or only real benefit in this case, for having a two-sided.
There are a couple other reasons
solution.
to use a set of soft jaws as well. In industry, a lot of soft jaws are used because they don't want to mar the part up. So if you don't mind having the teeth marks from the serrated jaw on like an Inception Machines vice on the side of your part, then that's absolutely fine. You don't need to worry about it. But if you are producing for a customer at the end of the day or something like that, you would want to use a softer material for your soft jaws than the hardness of the material that you're trying to mill. You oftentimes see people even 3D print soft jaws because you can, for something that's a facing op, which is relatively low tool pressure in a very predictable direction, right? A set of plastic soft jaws is pretty all right, especially at our scale where we're not really going past 10 millimeter diameter end mills, so we're not putting that much force on the part. When you get into higher industry and you're using 60 millimeter shell mills, then it might become a problem. But for someone at our level, 3D printed soft jaws aren't too bad of an idea.
Yeah, which is probably the way that I'll go, simply because these are parts that I'm hopefully only going to be machining once. So the expense of buying stock to mill the soft jaws will pretty much eclipse the cost of the parts themselves. And just in case there's anyone watching that doesn't know what we're talking about, soft jaws are not actually soft. They're just jaws to be used with a vise that conform to the shape of a part to hold an irregularly shaped part that can't otherwise be clamped directly. So as we're talking about here, where we really want the jaws of the vise to be on this surface and coming in from this direction, because we've got a circle, we can't clamp to that. So we're literally going to print something that will clamp into this area coming from the bottom where we've already milled, that will give us access to remove all of this material here.
Yeah, correct. As Jake said, the name soft jaw is because the jaw is normally softer material than the part itself. But yeah, they're not soft as in a rubber or foam. They're typically still what materials we would consider hard. So aluminium is a very common soft jaw material. Yep. The other point there that Jake also alluded to was the serrated jaws and marking the part. That particular vise, you can actually flip the little jaw insert to the straight edge side to reduce any marking. Just as an FYI, if you happen to own that vise and aren't aware that that's an option.
Yeah, I haven't flipped mine yet. When I machined the fixated clamp, I didn't bother because once the part was flipped over, the machined face that was going to get those serrated marks is the bit that actually goes into the fixated plate, so it wouldn't be seen. I know it's there, but I don't really care.
Yeah, exactly.
Those markings are so small anyway, unless it's a cosmetic part, you're unlikely to see them in practice, I think, at least from my testing with that vise.
Yeah, I may try it. Probably the first parts that I'm going to really design on my own and then mill out of metal I'm going to build basically a monitor arm to hold the flat screen that I have for the Milo on the side of the Casa. So those I might try to not mar too much. But so that much makes sense. I don't know if we literally want to go through setting up the operations. It's relatively straightforward.
We could speed run this quickly if you want.
Well,
so let's do it, because setting up WCSs is something, and the different setups is something that people regularly ask about in the Discord. So if we quickly run through it, at least you've got a...
Well, let me move us all over here. Okay, so here, let me go into our setup.
Yep. Cool. So we've already spoken about size of stock material and the position of the part inside of there. And there's various options which are pretty self-explanatory if you look at them in these menus that allow you to do that. The next thing that's in here is all about setting the WCS point. And now your WCS is your work coordinate system.
Mm-hmm.
So when you're doing CNC machining, you normally work in relative coordinates rather than absolute. On most printers, you'll set your homing position, and everything else from there is an absolute G-code position to that home point. On the CNC, you'll have your machine coordinates, and then all of your G-code will actually just be generated machine agnostically almost in terms of where the part is located on the machine, based on where you set that little set of axis that you can see in the corner of your stock material at the moment. So that WCS, the X, Y, Z orientation of the axis, is where the G code is going to set a 0 point and generate all the coordinates from there for the rest of the operations within this setup that you've got at the moment. What it's done, I don't know if it was default or you've set this, is it's picked the front left corner. That's basically most people's go-tos for a bit of square or rectangular stock, because it's really easy to see that corner and get a reference off of it. And if you lose your reference for whatever reason, you crash or the machine knocks down, you can normally pick back up off that corner, maybe just a bit lower down or whatever. The other options are you can pick in the middle, where you kind of get a reference off the front and back face and the two side faces and half the position to get the center. 9 Mile will probably talk about his homing and probing macros later that help you do all of that a lot easier than manually, as you'd have to have done it previously with RepRap firmware. Cool, so we're happy with that position. The only thing to note here is that the X and Y direction needs to be set based on how you're going to place that in your mill. So if you're placing your vise, such as you're looking at the long edge of the stock when it's mounted, then this would be set up correctly. If you are going to be looking at the short edge of the stock, you'd need to rotate that work coordinate system so that X was pointing along the short edge. Does that make sense?
Yeah, so I did set that up, and in terms of my machine... oh boy. So in terms of my machine, this would be the X-axis with Y going back.
Yeah, exactly. Which is cool. There's no right or wrong answer there, just so long as your machine setup matches what you've chosen and your setup here, you're pretty good to go.
Yeah, and given the work envelope of the Milo, that orientation makes the most sense.
Yeah. Yes, exactly. Right, so as you said, next we'll just accept that. We're happy with that setup.
Okay.
As you said, we'd probably do an adaptive clearing. So if you just want to quickly throw in the 3D adaptive toolpath.
3D.
So whilst you're pressing buttons, quickly introduce that. So adaptive clearing is a toolpath generation tool that will essentially try to normalize the loads on the tool bit throughout the cuts, so you don't get the peaks and troughs that you get in some traditional milling strategies. And that typically means you can do a bit more material removal rate a bit faster, without sacrificing quality or sort of stiffness, or achieve more with a lower powered machine fundamentally.
It's also worth saying that it should never be a finishing strategy. It's always a roughing strategy.
Unless you don't care about the tolerances on that face.
All right.
But yeah, so this is where what Jake mentioned earlier about knowing which features actually matter from a tolerance perspective is important. Because you could just allow it to essentially go down to the surface in any way you don't care about. And then it saves you the time of having to finish it later. Toolbit selection-wise, this is normally based on what you have available. But in terms of speed, use the biggest end mill that your machine can drive that fits in the features that you're trying to clear out. So on this, I'd maybe use a 6 mil single flute for the bulk clearance operation that you're about to do. And as Jake said, I would leave the 0.5 mil or 1 mil of stock on the faces to be cleaned up in the preceding operations.
Yeah, if it's a part I designed, then there's a good chance I've made the minimum radius 3 millimeters, so a 6 millimeter diameter cutter will be able to get into all the corners. Just a little bit of knowledge for anyone who does make anything that I designed.
Lovely.
The other thing you want to check to make sure that the tool you're using is as short as you can get away with to reach the depth that you want to get to.
Yeah.
The longer the tool is, the more deflection you'll have in the cuts and the less accurate it'll be.
Yeah.
Okay, so let's go back for a second then. All right, so are we going to set up this path to mill all the way to the bottom of the model?
Yeah, so you don't care about that bottom face that you're machining away into the stock. So I would set it to model bottom minus maybe 1 millimeter. That ensures that when you flip it and do your facing on, you get a really clean edge. You don't end up with like thin, like wafer thin shrapnel on the edge of your bottom surface, basically. So I tend to have my clearing go just below the part.
Right. So we've got 14.6 millimeters model height. So,
which means you need a flute length of at least 15, really.
So we would go, and I'm just using the tool library that probably needs to be a little bit reworked for the bits that come with the LDO, but for the moment we'll run with this. So a 17 would clear.
Yeah.
Okay.
Cool. So it's worth noting that when you pick that tool, when you actually set up that tool in your tool library, you'll specify things like the amount of the tool that's sticking out of the collet. That's important for making sure your collet nut doesn't collide with the part. And then it will specify the flute length. But Fusion will warn you if either of those two things are incompatible with the tool path you're generating. You'll get little collision warning things that will pop up.
Okay.
Yeah. So I'd set the parameters. You've got a 6 mil, so I'd probably go like 1,000 millimeters per minute and maybe a 1 mil step over.
Okay, let me surface speed.
Yeah, aiming for about 0.05.
I'm sorry, what's that?
So cutting feed rate at about 1,000 millimeters per minute.
Okay.
And then if you go over to the passes tab, then you can set your radial offset, I think it's called. Optimal load. It's called optimal load.
Okay.
Optimal load, yeah.
And that will dictate how much of the tool is actually being used for any one cut. So it's basically, if you think of it in terms of the width of your cutter, if you've got a 6 millimeter diameter tool, and you say it's going to be cutting with an optimal load of 6 millimeters, you're using 100% of that tool. Yeah. So a 1 millimeter optimal load is a good starting point.
Yeah.
Okay.
And then you can also specify your depth cut. So how far that you can attribute to being like a layer height on a 3D printer. How far in terms of depth are you going to be able to do with every single cut?
Okay. That's not linking. Where is the depth of cut? Is that...
It'll be in links, I think.
No, it's still in there. It's just called... It's in... If you're doing... if you're doing...
multiple passes.
An adaptive clear, it's your maximum roughing depth. So just under where it says climb cutting.
Right.
Yeah.
And where do we want that?
At about 1 mil is a good starting point. Again, these are all kind of starting points for recipes on Milo. If you want to push the depth even more, if you wanted to push the optimal load even more, please feel free to. You may break a few tools every now and again whilst you're doing some testing, but these are good starting points.
Yeah.
Okay.
You'll be able to push a 6 mil up to about 5 mil depths relatively comfortably.
Okay.
Cool. And let's just hit OK and let it. Oh no. So on heights, actually, before we do hit OK, this sets your reference heights basically for all of your operations. You've got clearance heights and stuff for what the tool's doing when it's not in contact. You've then got model top and model bottom down there. Yeah, so top and bottom. They're your actual machining heights. So it's only going to look to remove material in between those two layers, those two or the blue and purple one.
Right.
So this is where I would normally set model bottom to a minus a small number, minus 0.5 or minus 1. So it just drops that little bit below your part you're working on.
And then coming from stock top.
Yeah, stock top would be fine because that's going to start removing material from the top of your stock, basically.
All right. Well.
Yep. And then it will do its thing, and you should get rid of most of the material.
All right. Let's take a look. Oh, still generating.
Yeah. So because you've basically given it free rein to generate this whole toolpath, and because you've got relatively small optimal load and step down, it's got quite a lot of toolpath to generate, basically. But there you go. And what you get, which is nice in Fusion, is you get your in-process stock model. So you can see the state of the stock or what material's left over after you've done each of your steps. If this isn't working properly, you'll probably find that further up your set of operations, one of them won't have been generated or need regenerated, because every preceding operation needs to have been fully generated for this model to be accurately represented.
Yeah.
It's also, I keep saying this, but it's worth mentioning that I think when you program this part, you had stock to leave still ticked. Stock to leave is just it's effectively saying how much from each feature you want there to still be oversized, right? So that later on, because you can always take material away, you can never put material back in a subtractive process. So if you take away too much material at the beginning, you won't be able to go back and fine tune it later on. So that stock to leave just says how much stock I want left over after my roughing process has been completed. I think you left it at 0.1. So currently all the features on here are 0.1 of a millimeter thicker than they should be.
Is that enough material to then go back and do the finishing pass, or do we need to change that?
It should be. It should be enough.
Okay.
Yes.
Cool. Now's when things get a bit more interesting. So adaptives like your jack of all trades first toolpath, I would pretty much start everything I'm working on with an adaptive clear to get me close to where I want to be. Next, you want to look at the bits you need to finish. So if you look at the different surfaces we've got essentially a set of horizontal surfaces. And then we've got a perimeter that goes all the way around the outside of that part. And those have two kind of different requirements for finishing. One's using the bottom of the end mill, one's using the side. So it's going to end up being two separate toolpaths to do those finishing operations. So we're going to hop in. You've got a bunch of different options for doing the flat surfaces. You can either use a facing operation and set that up for the top one.
Mm-hmm.
Or if you're wanting to be cleverer, there is a 3D one called, what's its actual name? Horizontals. No, what's it called? Flats. It's literally called flats, which is like a smarter version that will set up essentially a toolpath that just finishes every flat surface that it can find and reach.
Okay.
That's quite a quick way to do things. Hopefully it's just kept the same parameters from previously. We'll probably use fairly similar speeds and so on for this.
All right.
If you tick rest machining, it just means that it's going to continue from the last operation that you used, rather than starting the whole process all over again and machining stock that isn't there anymore.
Yeah.
All right. So, do we need to set anything else, or is this just going to hit those horizontals?
Should be okay. I would probably just hit OK and see what you get now. We're expecting it to clear the top face and the little stepped faces. Thinking.
Okay, and that looks like what it's done.
See the lines? Looks like it. Yep. Yep. Nice. And then you're going to want to do a perimeter, just to clear out the rest of them. So that'll be in 2D. I think it's just called perimeters. 2D contour, sorry.
Yeah.
Yep. And then you're just going to pick the bottom line, basically, because you want the end of your tool to follow that bottom line around the part.
Okay.
Because everything's essentially a flat face that it can touch at that point. Yep, so when you're selecting 2D contours, you can select either the face or the actual perimeter line.
Okay.
And depending on what the selection gives you, you have to do one or the other in different circumstances. But that looks fine, because you don't have any like holes or things in it. It's just a single face. It should give you the right contour. And then heights-wise, again, I would step this down to the same height or just a little bit less than the bottom height we set last time.
Right. Which I believe we set to -1.
Yeah. Although
2D contour is feature dependent, so it always goes off the lowest feature that you do. It doesn't have a bottom height.
Okay.
There's an offset though. Yeah. Anyway, yeah. So you can do the 2D contour.
All right.
That should be okay.
Let's see.
And you'll just get that line. Yep. So it is.
Yep.
Yes.
So at
do
this
the little
point,
step and you're stopped there.
Yeah. At this point, once you've done the little step in the stock, it would either be time to flip the part over or flip it 90 degrees. And if you wanted to drill out the holes on Milo, you could do it that way. I would forego doing that because it's probably faster to go over to a drill press or use even a manual drill than it would be to program it. Programming is always going to be the thing that takes the most time. But if you go over to the setup, now if you click the setup on the little bar on the side, right, go one down, I believe. Yeah, and then if you right click, you should be able to simulate all the processes that you just had.
Oh, yeah, that's
and you'll be given a timeline. And it's always good to watch these. It's the same as when you simulate G code on a 3D printer, and you can watch each layer by layer form. It's always good to view it because you may have some crashes that Fusion itself has seen. It also gives you kind of a more intuitive idea of how your machine is going to move, so that you can check to see if things are going wrong. You can speed it up, slow it down, do as you wish.
So I would drag your the speed of your thing, the bottom, drag you bar at the bottom. Just watch it in high speed mode.
Yeah, I do want to
When
slow.
you're doing this, when you're doing this yourself, you're going to want to slow this down and just make sure that any bits that kind of seem a bit like a problem point, you slow right down to around normal speed and actually look in more detail. Is it actually a problem or is it actually okay?
Yeah, I was just trying to get it to the point that we get to the next operation.
Yeah, it might be worth also just if you see where it says on the side, it says toolpath. If you just click that, and it gets rid of all the blue lines and things, and you can see the part of it a little bit better. So further up, the little tick box.
Gotcha.
Because you can get a lot of lines, and they can kind of interfere with what you're trying to see after a while.
And okay. Now it's we've still got clearance there. I'll speed that up again. All right. And there we go. So
you'll see the different colors are indicative of the different operations that you're running. So the orangey beigey looking color is your horizontal. Your flat. Not your flat. Your 2D contour. The blue is your flat operation, and Fusion's quite good in that way because you can actually see which operations are which at a quick visual glance. At this point, you would simply turn the part over. This is probably where you'd use your soft jaws, clamp it, and then you would just run a facing operation over the top until you get to the right thickness.
right. So I know for me, because I don't have a drill press, those holes become a little problematic. So one of my questions is, let's say that I do have a drill press, or even if I want to manually drill those out, would it be possible, after cutting the part entirely, so the only feature that we have left is the hole, to be able to orient it upward like that, even if it's, here, let me get a little tilt, even if I just use something like a chamfer bit to give myself locating marks on these surfaces?
Yeah, that's more than possible. I've
100%.
done the exact same thing in the past, where I've taken the chamfer bit. I've used a drill operation, but instead of putting a negative bottom height on a height tab, I've put it to the same height as the top of stock -1. That way, it will only go about a millimeter into the stock. Right. So that's where the height tab can become quite powerful. With things like that, and that will give you the same as a center punch or something like that for locating a drill.
Because I do have a neighbor that has a machine shop in his garage. He hand builds titanium mountain bikes. So I'm sure I could get him to drill a couple of holes for me. But if I could come down and say, hey, these are already indicated, this is the diameter, it would take him all of about 10 minutes.
Yeah, 100%.
Yeah.
You'll be able to clamp that part in a vise to just do that marking. Yeah, I don't think you'll need any special jaws to do that. Just be careful when you're placing it in. I wouldn't put it on the low profile edges. I'd put it right in the vise so you can clamp a decent
Mm-hmm.
amount of the side of face, and that'll help keep it flat as well.
Okay.
It's just what you need to be careful about when you're doing that marking.
I think
It's at that point that. Oh, go ahead, Nigel. I'll let you figure it.
I was going to say I think you probably need it in the bottom of the vise anyway, just to have enough clearance to get a tool in there. It's quite a high part.
Yeah.
Yeah, there is also the option. I know we went on earlier about how every nail looks like a solution a hammer could fix, type of thing. But if you were setting up an operation to, if you're willing to go through the step of setting up an operation to mark it like a center punch anyway, you might as well use the same tool, flip the part over, and perform a boring operation. I'd hesitate to tell everyone to do drilling operations on Milo because our spindles are simply too fast for a lot of drilling. It is possible with small diameters, but if you're doing anything kind of, unless you have HOI already installed, I would caution against using drilling operations because you'll get a lot of flex in the column,
Okay.
which will mean that you're not drilling straight down. If you do have HOI installed, perfect. Just realize that you need a carbide drill and not high-speed drill bits because they will break. And our spindles are simply too fast for normal high-speed steel drills.
Okay. Well, since we are here, do we want to do the second setup just to get that top hat removed? Because I think I have seen some comments that people are sort of like, once they have to move the part, then it all goes a little wonky.
Yeah.
So I'll put that back where we had it. And we'll create a new setup.
Mm-hmm. So this is where Jake mentioned to it earlier, but you need to make sure you've got rest machining ticked such that it uses the stock from the previous operations. I can't remember the exact checkbox name from memory.
Continue rest machining.
That'll be the one.
Okay. But now we need...
And then stock mode should be from preceding setup.
Yes.
Rather than a fixed size box or
right
we had before.
So now we need to go back and reset our WCS.
Mm-hmm.
Which, let's get into... Ugh. It's never easy. 3 dimensions, one too many. Come on. Space Mouse is supposed to make things easier. All right.
Yeah. But essentially you're trying to do what I'll quickly explain that the goal is we've flipped over this part physically, we put it in our soft jaws, and now we're going to we need to work out where the new location of that material is, because it will have moved from where it was before.
Well.
And so you're going to pick a WCS that is either a top corner, or if the thickness of this part is really important, you can actually reference the Z height off of the locating face on your soft jaws, because that will set the Z for your part rather than the Z for a random bit of stock material. And then your X and Y, because we're just doing a facing off, can just come off the corner of the stock material.
Right. So, since we don't have any of the soft jaw model in here, do you want to just go back off this corner?
Just pick a corner.
Okay.
Also, the thickness on this part doesn't really matter too much. If it's a fraction of a millimeter off, it's not going to affect the fit.
You can always. So the nice thing is that you can make. There is a certain amount of things you can do at machine. So for certain processes where you won't have to go back and re-simulate everything. So if you're just doing a few passes to get the thickness down, and you notice that your part is a bit too thick, instead of going all the way back to your computer and reprogramming it all, just go to your 000 work coordinate system, bring it down by the thickness that you are over the part, and then re-zero at that point, and you'll be able to just run the exact same code again, and you'll get to your desired thickness.
Okay. Okay, so there is the part. We've got the axes going in the correct directions based on the vise position that we used in the previous setup.
Yeah, so you're essentially flipping it over and then zeroing off the front left corner again.
Yeah.
And the height will be different from the previous setup, holding it different.
Check the second tab. I don't think you are missing the continuous machining in from previous version.
Yeah, we've got that now. So then
you might also want to change the work offset in the setup. So you're using a different work offset in the post-process tab. If you just change the WCS offset to 1.
Okay.
Use G54 for the first thing, and then when you flip it, it will ask you to re-probe the G55.
Okay, I thought it did that automatically, but
it will for G54, but it won't then, because it's not changing work coordinate system after that point, because the first set of operations is already in G54. There wouldn't be a change for flip, so it wouldn't ask you to reprobe the 0 point.
Okay.
That's from a MOS side of things, not just that's MOS specific.
Okay.
That also depends whether you export the entire every setup in one go.
Yeah.
Or if you just export one setup at a time. If you export one setup's worth of operations at a time, you're essentially starting from fresh as far as MOS and any machine's implementation is. So it'd accept G54 as the first offset anyway.
Yeah, that's why I thought that, because I am one of those poor souls that's using Fusion. So since I've gotten it now to successfully at least be able to export a number of operations that all use the same tool within one G-code file. But normally, for example, like when I did the fixated clamp, I did the last top operation, which would have been the chamfer, and then when I flipped it over, it was a tool change. So MOS prompted me saying, I currently have this WCS. Is that correct? Or do you want to reset? Which I said, well, yeah, we need to reset because we physically moved the stock.
Yep. Yeah, that prompt will only happen when Millennium OS thinks that a probe is needed because something's changed. If there's no change to the a work coordinate system from a post-processor side, then it won't know that it needs to probe, regardless of whether there's a work coordinate system already set or not. So that message just won't come up. It'll just use whatever was set previously.
Okay. And I am still running in tutorial mode because me. So
yeah. I was just going to say there's no downside to changing the WCS offset, at least from a Millennium OS perspective. There's 9 work coordinate systems you can use, so as long as you're not overwriting them, it's fine.
Okay. All right, then we'll assume this setup is good. And we can see our left material there. And then we want to use a facing operation.
Yep, facing is an appropriate operation.
Okay. And still using that 6mm bit. Should be able to deal with the stock. And we're going... So do we want to do... So for this face, would that be one operation, or do we want to do a cleanup pass?
You can do a cleanup pass, but you can do it in the passes tab rather than doing it through heights. So if you go to the passes tab, right, then you go to stock to leave, very bottom, and click that. Perfect. And then if you leave, I would normally leave anywhere between 0.5 to 0.1.
Okay, so we've got that there.
Yep. And then all I would do is I would confirm that, make sure that the G-code worked.
It's
cool. And then if you go over to that facing up on the left bar, yeah, right click it and click duplicate.
Right.
Perfect. And then go to that one, go back into it, edit it, and then just unclick stop to leave. Perfect. There you go. So you've got effectively the same operation going multiple times.
Right.
There's one bit that we missed out, and it's probably too deep a cut for Milo at that width cut that we're doing. So you would probably go back in and go over to multiple depths. So click multiple depths. And then you would choose your maximum step down, which is set at 1mm. And then you would go to what's it called for this? Step over.
Mm-hmm.
And it's the same setting as before. An easy setting that will probably work is 1mm step over 1mm depth of cut.
Okay.
That will work. That's a safe bet.
All right.
Yeah, it won't really matter for the other setup because you're cutting such a thin layer. Your Milo will be able to do that.
Yeah.
There's not too much load on the tool.
So we can go back to here and take a look at that. And again, I will try and zip through that. And there we have everything except dealing with the holes.
Yep, exactly.
Excellent.
If you'd like... Oh, go ahead, Matt. No,
you've got a full set of HOIs.
Well, I've got 25% of a full set of HOIs. But essentially, milling the other 3. Well, obviously, one of them is just running the same set of operations again and then doing the same operations on another model.
Yeah, exactly. You kind of have a core set of operations that you would use. I think you could probably you could probably machine 90% of parts with facing, parallel, adaptive clear, horizontal, and flat. Those are the only 5 that you really should know. There might be another one that I'm forgetting, but you can get away with the majority of parts with those operations. I don't know if the others would agree with that or not, but that's kind of how I would view it. So as long as you learn those 5, you should be fine for the majority of the time.
All right. Well, that is all very helpful. I'm going to go ahead and jump out of this and come back to here. And again, once the G code is generated and that's thrown into the Milo, the MOS, I can't imagine having to run my Milo without the touch probe and MOS. It's easy mode. It's so simple.
I'm happy to hear that.
No, it's fantastic. And even when I did the fixated clamps, when I did the final chamfer, being able to go in and easily use the radial bore finding was so easy. And now I really can't wait to get back out to the machine, because since I've got the pendant installed, it's just stupid. It is so much easier to just take that and be able to drive the touch probe exactly where I need it. And I did look through the code. The one that I got actually is set up for a 6-axis. So I think I've figured out how to tweak the Arduino code so that I will be able to go set it to like axis 5, hit the select button, and that will just home it. And then I am going to duplicate I can't remember which code it is, but that park front macro.
E27.
Yeah, to be able to just bring the bed forward so that I can put my stock on.
Yeah, I think that's the only usability issue that I have with RepRap firmware, is that, or at least with Duet Web Control, is that the touch interface for jogging is dangerous in certain cases, and that's nothing that you can say about Duet. That's not their fault. It's just touch interfaces are sort of susceptible to that. Like sometimes when I'm jogging stuff around to find a corner, I'm using a touchpad on my laptop, and I pick the laptop up and I go to move the mouse, and it's over one of the buttons and it activates it and jogs. And that's, yeah, a pendant is pretty important, I think.
Yeah.
Jake is struggling with the mic.
There we go. Sorry.
Yeah.
Sorry. I went over to check Discord and none of my hotkeys are working. There is a project in the works at the moment by someone in the community that looks really, really promising for a wireless pendant. And I am, if he makes it work, he may be part of the team at some stage sooner than later, because that is going to be a big upgrade in terms of, like Nomal said, just from a safety perspective.
Yeah. Yeah, I've seen it and it looks very cool. I have to admit that I'm old, so I kind of like the security of the hardwire. Makes me feel a little more comfortable, but no, the industrial design on it is gorgeous, and I love the idea of it. I think what I'm going to do, I have a number of, they're described as some kind of aircraft connector that we've been using as quick disconnects for CAN bus wiring on the Vorons. I'm thinking about making a switch blank to go into one of the switch positions in the front of CASA to be able to just wire my pendant through there, have a quick disconnect if I need to remove it for any reason. Right now, I've just got a pigtail coming out of the back of the Milo to, I think it's a 3-pin Molex connector, which is at least locking so I can disconnect it for service. But Yeah, it's a real usability improvement, and I've been very lucky that I haven't accidentally crashed the touch probe, but there have been a number of times where I go to move it in one axis and accidentally hit Z instead of Y, or that sort of thing. So it
Yeah, we have a
also,
meme for that.
yeah, and it lets you not worry about sort of looking over to hit a touch screen and splitting your attention to see what your position is. You can literally just stare directly at the spindle and then just tactile move everything around.
Yeah, it's one of those things it will change the game for us specifically. Um, there's a lot of stuff in the background that's going on that's kind of the same level, and I can't wait to share it with everyone. But we need to wait until that gets
Yeah,
around.
it really just, when I looked at the project on the Duet Wiki and was like, wait, so you've got an Arduino that's spitting G code directly into the display port. Okay. But it works very well. So
I actually have a little project for you that I've come up with while listening to this. The touch probe, when it moves using calculated moves, already does protect itself. So it looks at the probe status and then moves. And if the probe activates where it didn't expect to activate, the machine will just stop. So if you want to get all technical, you could try and change the Arduino code so it sends the G code for a protected move instead of a normal move. And then even like with the pendant, if you ran it into something, it would still stop instantly. It's worth a
I can tell you that's a really nice feature. Linux CNC has that on enabled and jogging by default. So it's actually really hard for me to crash the touch probe just by jogging. Unless if you get
There's
to
the only
wire
one on the team who has.
At a trade show.
The only one on the team who has.
In which case it'll go wrong.
well, if you would send me the information, I would be happy to try that out in my pendant firmware.
Absolutely.
Because now I have to get ready to go mill some things.
I have found that after sort of 9 months of having the machine and thinking about stuff and trying to work out how to machine stuff and all this sort of thing, there is no substitute for just ramming tools into things and seeing how the machine responds. I wouldn't say it's intuitive, like your natural response is to want to slow things down and like run things at 10% speed or that sort of thing. But like it's quite, I don't know, it's sort of visceral in the feedback that it gives you. It's very obvious when something's not working the way it is. And I don't think you get that experience of using the machine unless you actually sit there and you cut things. So for anyone else that ends up listening to this, or for you, I think just actually running the machine, testing toolpaths and seeing what happens is so important. And yeah, like the risk of breaking tools is sort of high when you first start, but I think if you stick to my approach recently has been being relatively, or feeling like I'm being relatively aggressive when it comes to speeds and feeds, but being sort of very careful when it comes to step over and step down. That's the way to approach it, because it's very obvious when you've gone over the top on step down and step over, but it's not so obvious when you're dealing with like a speed mismatch.
Mm.
Yeah, there really is no replacement for like hands-on knowledge when it comes to CNC. I know a lot of people get very intimidated by it. We have a load of requests to build software where it just does it all for you like a slicer does. But the issue with that is it could work. I can see a space where it works, but you lose so much of the power behind knowing it, and there is no replacement for that knowledge. So I really do encourage people. I think we all do on the team, just to, like Nine Mile said, throw tools at a block of aluminium. If they snap, they snap. They're relatively cheap. There's no way to replace that knowledge.
Yeah.
Even just watching someone else do it, you just got to get hands on in it, get your own style with the machine.
Yeah. And I've seen now at least two of you milling threads. Do you have any or let me ask it this way, have any of you looked at the thread mills available through Drinique?
Yes, I think both of us used them.
Okay.
I think mine are definitely Drionic thread mills. But they're aluminium coated, so they're not brilliant. They work, but you need to be a bit careful milling aluminium with aluminium coated.
Yeah.
thread.
I thought it was the same coating as the end mills. Or maybe I'm thinking of a different thread mill.
I haven't seen any Drionic DLC coated ones. You know, the multicolored one. They're usually the TIALN
Right.
is like a grey coating.
Here, let me. Now watch, it's going to pop my browser up on the main screen and it'll get recorded. Oh no, lovely. Just trying to find where I had these saved. Oh, there we go. So I will throw, where is, oh, come on. Going to just throw a link to this in chat. Boy, is that ugly.
Those are different than the ones that I used. They've got two cutting edges. I don't know if they call them two fruit or whatever, but yeah, they're different. That's the right coating, I think.
Yeah. The difference between the single tooth and multi-tooth is just the speed you can essentially cut the threads. But if you get one with multiple cutting rows, teeth, you essentially are stuck to literally just that pitch. You can't do like a 30mm M2 spaced thread, for example. That'd be a stupid thread. But whereas a single one you can.
Yeah.
That's kind of the only real difference. But yeah, that's the correct coating. You want DLC style, not any of the ones that have a AL in the coating name. Because the affinity of aluminium for aluminium causes them to stick up quicker.
It's a recipe for chip weld.
Yeah, and I broke the first one very, very quickly doing that. So.
Yeah, because I should order another one of the, or if I don't get the actual Milo starter kit again, I at least need to get some backup end mills, because I'll do something stupid eventually. I have faith in myself. So
yeah.
I just thought
those 3mm ones break very easily.
Funnily enough, it's not people being too aggressive with them. A lot of the time, it's just cheap collets that cause the 3mm ones to break, because they don't have the 3mm ones are really, really sensitive to run out. And if they've got a run out tolerance of like 0.05mm. So if you're using cheap collets on your spindle, they will break.
Yeah, I don't know how good my collets are, so I might want to upgrade a bit.
My comment on that is, with the ones of AliExpress, you more or less don't know what you're getting. Some will claim to be AAA. Some will just claim to be A, but they're all just a mix of essentially the same collets if you're only paying £1 per collet. On the flip side to that, you're using a Chinese spindle. So there's absolutely no point spending £100 a collet on a industrial high-speed balanced beautiful thing from Rego Fix.
Yeah.
So there's a there's a balance to be had there.
Don't tell the community what to do. You know we've got mad people in this community.
No, there are some reasonable outlets for, somewhere in between the $100 per collet and the, you pays your money, you gets your chances from other sites. I actually saw a set from Haas that was not horribly expensive. So, and the TIR on it was reasonable.
Yeah, the thing that will surprise you there is a lot of them aren't. So all the ones on AliExpress will claim to be 0.02, whatever the AAA is, whereas you'll get a set from Haas that will be 0.08, and that is just like the standard that a lot of machine shops will be using quite happily, but it is actually 0.08. So,
Yeah.
As you say, it can get what you pay for sometimes, and a known source of a worse level will probably end up being better.
Yeah.
Or at least more consistent.
At least consistent, as you say here.
Yeah. So that might be on the upgrade path, because right now I'm just using the ones that came with my Stepper Online spindle. So,
Which again is absolutely fine. Like that's kind of the fun of this kind of community and the people who are in it. It's always finding ways to do the most for the least, or the least for the most. And that's why it's way more fun than just buying a Tormac off the shelf or something like that.
yeah, and also from a budget standpoint, at least now I can kind of separate, the expense of the Milo and the expense of the Casa, which is helpful. So, well, again, we'll see kind of where the market goes, but
it kind of still feels like there's a pretty big gap between, like, affordability wise of Milo compared to what it's actually capable of. Like, I think there's a lot of areas where you can upgrade the machine and still have like a big price difference between it and a similar professionally made machine. So there's a lot of scope there for actually like making gains and using the machine to build stuff. And yeah.
No, I'm definitely looking forward to getting into more projects with it. It's a little more difficult just because the nature of the machine, and this is not a knock against the design at all, but because it, doesn't have a tool changer, it is a much more hands-on. I'm not really, and I'm also at this point not comfortable enough with the operations that I've set up to say, all right, well, I'm going to get it going, and then I'm just going to wander back into the house and go do something. I'm standing there making sure everything is going correctly, which means I'm standing there during the entire process, where at this point, I come up with a part that I need printed with my V2, and if the machine is already on in the garage, I just send it. And, it will periodically send me updates and let me know how the job is going. So it's a very different thing. And it's just having the time to be able to stay with the machine, do the tool changes, do the probe when setups change, that I just haven't had since before the Rocky Mountain Rep Festival.
Yeah, and that's completely understandable. CNC in general, even at an industrial level, requires an operator, because things can go wrong. And if things go wrong on a 3D printer, oh, you've lost a print. If things go wrong on a CNC machine, there's a potential for actually hurting yourself quite badly. So having an operator there is actually something that I think is more required. So there is that level of commitment to it. I remember when I first started running my V1.4 properly, I if I needed to go grab a drink from the kitchen or something like that, I would run as fast as I could to do it. Whereas now that I'm a bit more comfortable, I can leave it for a minute or two and expect it to run fine. And that's just the big difference between CNC and 3D printing.
Yeah. Cool. Well, is there any? Go ahead.
There's always going to be that squeaky bum time when you run a toolpath for the first time, and you just aren't entirely sure what's going to happen. But I think I've run a couple of things like multiple times now, and like you do get a lot more comfortable with being able to sort of step away for a bit. And I definitely find having a phone that can access the web control with an emergency stop button on it a bit nicer to be able to walk away while it's still on the Wi-Fi. And,
Yeah. Yeah, and I'm going to have multiple emergency stop buttons. Yeah, my apprehension is solely based on my own programming. So, like, did I do something stupid? Do I have too much depth of cut? Well, let's find out. But yeah, letting the machine do its thing and and it's also fascinating to watch. I do enjoy it. I'm sure at some point it might not be as wonderful, but at least for now, it has that same kind of magic as the first time I ran a 3D printer. And it's like it's squeezing plastic, and then it's squeezing plastic on that plastic. Ooh, it's like printing plastic in midair, like doing an overhang. Whee! And now it's just like, wake me up when the part's done. So,
Yeah, I think there's a lot more of it in CNC world because, like we alluded to earlier, setup is a big part of it, and there's so many wonderful and weird ways to do setup of parts, and so you always get that kind of I don't know, attachment to different parts that you're making. Whereas a 3D printer is a lot of the time it's you do one print. Oh, I want to do an entirely different print, but the actual process is exactly the same, right? CNC from part to part, it's always going to be different. It's always something new to do, always something new to learn.
yeah.
Unless you're running the same part over and over again.
And you really have to think about it, whereas 3D printers nowadays, you can pretty much click slice and you've got something pretty much ready to go. So.
Yeah. Well,
right. I'm going to have to drop off, I'm afraid, guys.
Well, I was going to say it's now pretty well into your evening, and I want you to be able to enjoy your Friday night, but I really appreciate you hanging out for a bit and just chatting about everything you've been working on and going through setting up some basic operations. I'm really looking forward to doing the HOI. The only downside is now I have to reprint the spindle mounts. I do want the covers; they look pretty. So
don't worry, we've got a plan. Well, we're trying to figure out a plan for future so that you don't need to constantly reprint the same part in different variations.
Cool. Well, thanks again. Have a great weekend, and hopefully I'll be talking with you soon. And seriously, 9 Mile, if you want to send me that G code, I will see what my pendant does.
Sweet. Remind me next week.
All right.
All right.
All right. Take care, everybody. Thanks again.